Hello and good afternoon, guten Tag or dzień dobry, wherever you are in the world today. I hope you can see me and hear me well. Welcome to another webinar of IDEA StatiCa. We are happy to see so many attendees of our today's session. This one is dedicated to prestressed concrete and is entitled FE Analysis of Prestressed Concrete Beams with Large Openings. My name is Maciej Kwarski. I'm a product engineer at IDEA StatiCa Germany office, and I'm joined today by my fellow colleague, Aristidis Iliopoulos. Hi, Aris. How are you?
Hi, Maciej. I'm fine, thank you.
Thanks. Aris, could you please introduce yourself briefly?
Yes, my name is Aristidis Iliopoulos. I studied civil engineering in Technical University of Athens in Greece. And thereafter, I did my PhD in Germany in Ruhr University, Bochum. And I worked there mainly on composite bridges. Then after, I worked in many different engineering offices and companies, especially in Finland and Germany. And my experience comes mainly from the area of bridge engineering.
Great. Thank you,
And I'm
Aris.
very happy to work for IDEA.
Yeah, great to have you in our
Yes,
team.
thank you.
So let me start with the technical stuff. So this webinar is being recorded and will be available after today's event. We are running on the GoToWebinar platform, which means the audience is muted by default, but feel free to ask questions during the webinar. You can type them into the questions sub-window and we'll try to answer them at the end of the webinar. If there still be some questions left unanswered, you will get the answers after webinar via mail. Okay, so right now, Aris, the virtual stage is yours, so you can proceed with the presentation.
Thank you. Okay, please tell me, Maciej, if you can see my screen.
Yes, I can see your presentation.
So I will start with a short introduction on. Sorry, I have to put off my camera. Okay, I will start with a short introduction on the program RC Detail, especially for those who hear about the program for the first time. The program Detail is a non-linear finite element analysis program for a reinforced concrete structure and prestressed concrete ones. We can verify the ULS, I mean the ultimate limit state, which means bending and shear capacity. We can conduct also verification about serviceability limit state. It means limitation of stresses for all of the materials, concrete, steel, and prestressed steel. We can also calculate numerically the crack width, which means that we can conduct limitation of cracking. And we can also calculate the deflections, taking always into account precisely the cracking of concrete. What is very important about this program is that we can conduct detailing. That's why we have the name, detail, which means that we can investigate introduction of local forces, if you have, for example, point forces, and we can calculate the necessary splitting reinforcement. And also very important is that we can investigate discontinuity regions. For example, if you have difficult geometries or if you have openings, which is with beam elements or with a linear analysis, it's almost impossible. What I find very cool about this program is that the Stratton-Tie models are calculated precisely from the finite element model. I know that many of you in the past you tried to calculate with Stratton-Tie models, and in this case you have to make a lot of assumptions. If you work with detail, you need to make many assumptions. For example, the inclination of the compressive strat, or how many tensile strats you have, or where you have them. You do not need to think about it. You just take it directly from the program. Some information about the theoretical background, what is behind the program, because it is not nice to use the program as a black box. It is a 2D analysis program. I mean, we work on a plane, and the concrete is modeled through cell elements. The rivers modeled through truss elements. It means that they can only take normal forces. And between the two, there are shear field elements. And these shear field elements, we can calculate stresses. What does this mean? It means that if you have the bond stresses, it means that you can investigate the required anchoring length, which is very important. You can see that all the physical non-linearities are taken into account, but also different types of anchoring. If you have hooks or if you have other types of anchoring, you can include them in the model, and they are taken into account as springs. If you ask now, springs, it means stiffness, where this stiffness comes from. It comes from the recognized literature and, of course, from experiments. Let's go now to the next important information, which is when we're talking about concrete, it means we have to discuss also the main issue, which is cracking. So the program calculates numerically the strains in the rivers, and then it integrates the strains, so we get the crack width. So numerically, we calculate the crack width, and we can compare it with the limit value of our guidelines. If you have the strain values, also the curvature is known at different points along the beam. So the program calculates numerically, I mean, integrates numerically the curvature, and then we take the deflection under consideration of concrete cracking. Creep is also considered, and of course, as said, all the non-linearities. So application, where can I use this program? So all the structures where the geometry is a bit challenging. We call them discontinuity zones, like openings, etc. If you have local introduction of forces, for example, consoles, this is also very interesting. Prestressing, for today, we have a very interesting example with a pretension prefabricated beam. In bridge engineering, for example, the supporting beams that usually they have openings, they are really challenging. If there are any precasters today that they participate in our webinar, I know that you're fighting every day with single point lifting. You can have precise analysis with detail about such situations. Joints, and of course, a hot topic that we have mainly here in Germany, but I think it is a very hot topic in many countries, is the existing structures, the older structures. You can calculate precisely the strength of older structures, and you can investigate anchoring length, because most of these structures, they have anchoring details, rebar details that do not represent the modern codes. So it is a program for conducting a reassessment or calculating the strength of the existing structure and making conclusions about the strengthening measures. So let's go now to the $1 million question that many times we hear from engineers here in Germany where we work. But I think it is an extremely important question. And this question is, can I trust the program? I mean, this program was developed in ETH Zurich from Professor Kaufmann, who is world known about his research on concrete structures. And in our internet site, you will find also a book that was written from ETH, which is full of very important information about theory of concrete structures, but also full of verification examples. It means, what is a verification? Verification is a comparison between experiments and numerical simulation with detail. So the Answer to this question is yes, we can trust it, and there are thousands of engineers worldwide that work with this program. Another question that we hear many times is the program compatible to the modern guidelines? I know that there are many engineers that for many years they work elastic, and they're not experienced with nonlinear analysis, and then they make this question. I mean, is it allowed to calculate nonlinear? Yes, it is allowed, and for the European engineers, you can find the paragraph 5.7 when you can see that it is allowed to calculate non-linear, but do not forget to take into account your national annexes, because there are different informations from country to country referring to nonlinear analysis. Okay, another question is, how do I work with the program detail? So the first step is to conduct a linear analysis. Linear analysis and with this linear analysis, with this elastic analysis, you have to find the rebar layout, the necessary quantity of rebars or of pre-stressing steel, and thereafter all the challenging areas. If you have openings, if you have an area when you are not sure about cracking, then you have to work with detail. Detail is a detailing program. It is not a program for global analysis. If you work with program for global analysis, then you may have your own favorite 3D program. Our proposal is to work with BIM, because it is a program that it is used by thousands of engineers worldwide, and also there is a connection between BIM and detail. BIM is with BIM elements. Unfortunately, we see younger engineers that they try to conduct global analysis with detail. So this is the right way to work. Do not forget, first the linear or the elastic analysis, and then after the detailing. And with the detailing, you can optimize the rebar layout. Another thing is that sometimes we give the impression that detail is only if you have openings, only if you have discontinuity regions. This is not correct. In most of the engineering offices, possibly all of the engineers, they conduct a double checking. It means that they want to double check the results of the BIM elements. If you have detail, it is a beautiful program to secure the quality of the results. It is a comparative analysis. So if the results of the BIM elements and the cell elements are the same, then it means that you are in the correct path. I mean, similar, not. But if they're not, and you have differences, then it means that something goes wrong. Something, possibly you input something, the load, or maybe there is somewhere a mistake. Okay, let's see now our today's example. Today we will conduct the analysis, the static analysis of a fabricated beam. It is a prestressed beam with pretension, and it has 38 prestressed strands, and it is an inverted P-beam, which is quite common, as far as I know, in different countries. Cheap solution, that's why we wanted. This is how the beam looks like on site at the right, and at the link side we have some hollow core slabs. These are prefabricated slabs that they are also pretensioned, and they are really common not only in Europe, but as far as I know, also in different countries like in United States. And at the end states, it follows the concreting. The joint fabricated beam and the on-site concrete is not reinforced, which means in my analysis, we only take into account the cross-section of the prefabricated beam. Okay, and this is how my system looks like. It is a simply supported beam. The length is 13 meters. And you also see that there is a precumbering there of 115 millimeters. It is a strong precumbering value. I know that many times it is not advisable to have such strong precumbering values, but many times it is unavoidable. You may have an architect who is very demanding, and he wants or she wants a very slender beam, or sometime and you have problem with deformations and you need a precumbering. Sometimes there are other reasons. For example, in bridge engineering, the road layout is curved. I've done some bridges that with curved prestressed beams. So in this case, you have to take the precumbering value in the static into account. Otherwise, you will not have the correct results. Today, I will work exclusively with AutoCAD. I have to say that I'm not very experienced with AutoCAD. I needed for this system to give it in AutoCAD something like 8 minutes. So if I need 8 minutes, if you're experienced with AutoCAD, you may input this in AutoCAD, let's say in 4 or 5 minutes. I work with polylines, and the cool thing with polylines is that you can input in this field here the diameter of the rebar. So it means that you can give the complete system in AutoCAD. So I'm changing now, okay, to the program detail, and I'm saying, okay, I want a new project. I want to work with the Eurocodes. With a concrete grade, I'm satisfied. With a reinforcement, I'm satisfied also. I don't care about the concrete cover because I put all the dimensions and the concrete cover in AutoCAD. About pre-stressing steel, you have a variety of different qualities here where you can change the one that you want, and you can change also the system of the units. You can work with templates. I don't work with templates today. I will work with AutoCAD. It is a DXF file. So at the left side, I have my navigator, and this is the only thing that I need. I don't need any books. I don't need somebody to tell me what to do. I just have this navigator, and this navigator shows me how to work. I import my DXF file. I just have to remember where I have it. Here I have it. Okay. I worked in AutoCAD with centimeters. This is very important. And I choose my lower flange. With control, I chose it, outline. I have it. And this is my web. And I go outline. I have also some openings here, big openings, real big openings that I have to take to consider them. As you can see here, the geometry that I used in order not to have any stress concentrations. It is a chamfer. I think that the right English word is chamfer. This one, and I'd go to opening, right? Okay, I think this is my finite element model, and I export it. Okay, and the next thing I have to do is to input the right thickness, which is the width, 1.1 and 0.3. I go to the 3D rendering in order to see if is it the system that I want. I mean, okay, this is what I want. All right. So I have to input now support conditions. There are different types of support conditions with metal plates, line supports, point distributed. I mean, rigid supports. I work with this point supports, and I just to refer now to the right edge, which is number 5. Okay, I just move it some 10 seconds on the 10 centimeters on the inner side. I just copy now. Okay, I don't want to have a support in the longitudinal direction, and then I refer to the edge 7. Okay, and it is from the end. I think this is the simple support pin that I want to have. So let's go to the step 2 right now. Okay, the first load case is I can put a description here, SW. I go to load impulses. I add self weight. I want both. It means the lower flange and my web. Okay. Again, a load case. Let's say that this is the superimposed. I just write here superimposed. It's okay. It's a permanent type. And then I just put the line loads, and I want to work with the DXF file. This is my DXF. I do not forget I worked with centimeters in AutoCAD. You can work with the unit that you want. I choose the edge that I want. I select it and export it. And I have the line load. As you can see, it is, in my case, 17 kilonewton per meter. You can have, again, one line load. You can have also point loads if you wish, whatever. Okay, centimeters. And I choose the edge that I want. I select it. And sorry, it didn't work this time. Check that. 17. I just go. I did something wrong here. Centimeters. Okay. Let's select it. Yeah. Okay, let's use the edge. Edge 1. Okay, I think it's okay now. I just put the right value. Yeah, okay, 17. Okay, and then I copy this load case. Okay, here it is. And I write it is the moving load. It is the variable. I just put here var. Okay, I do not forget that it is variable in order to have the correct safety factors, combination factor, and I just put here the value that I want, 20. Okay, and just put here 20. Right up again, 120, 20. I think it is okay now. Okay, and it is a pre-stressed structure, and I want pre-stressing. I just put also pre here. Okay, I have my combinations. Ultimate limit state. If you don't want to put the description here, you don't need to put it. And now I have to be a bit careful because I want to input my safety factors. 1.35, 1.5. I mean, take a look in your guidelines, and I don't know what kind of safety factors or combination factors you have. I just use the European ones right now. I just copy. This is the characteristic for the serviceability. Just put the correct factors here. 1, 0.6, and I leave the pre-stress like this. In Europe, we have also for pre-stress different pre-stress combination factors. We call them R-inf and R-sub. You have to consider them. I will leave it in this example like 1 because I don't want to make it complicated for the colleagues that are from non-European countries. So I just copy again, and I have the quasi-permanent, for example. I put it here, QS, and about the variable loads are with 0.2. You can put 10 or more load combinations. I will work with 3 of them right now. I don't want to calculate the load cases because it will take more time. And now I think that I am ready to go. Now I will give you a tip. Let's go to check, and let's go to settings. When you conduct detailing, you have to use trial and error. You will have to conduct 2 times, 3 times, 10 times an analysis. And you optimize the rebar layout. And you have the rebar layout that you want. So the first analysis, and this is my proposal, is to work with a coarse mesh, which means finite elements that are not very small. And in this case, the analysis will not take a lot of time. So you go here, the multiplier, I just put the value 5. Okay. The last analysis, what I want to have. This is what I want to send to the draftsman. Then you can change again the multiplier, put here 1, and then we will have very small elements. We put here 5. And do not forget, I don't know if correct values according to the guidelines of your country. For example, in Germany, it is not 1, it is 0.85. Okay. And I have also my reinforcement, very important. I go now to the input. I go again to DXF for my rebars. So in this case, you have to work a bit slow in order to be fast. I can input all the rebars at once. If you start working like this, it is the possibility of making a mistake is really high. So take your time and give the rebars slowly one by one. So I give the longitudinal ones. And I select them. And then I have in my system the longitudinal rebars, as you see. Let's assume now that you forgot in AutoCAD to give the rebar diameter. It's not a problem, you can change it here. I mean, 25 and I can have 4. It's quite simple. .25 and I have 4. 25 and I have 4. And I take a look also in the 3D rendering, how it looks like. Always step by step, not all the rebars at once. So let's give now the tendons. Centimeters. As you see here in the DXF, I work with different colors. And you see these are the tendons. You see the first part of the tendon is blue. And this is the introduction length. It is the length of the pre-stress. It starts from 0 value and it takes the final value at the end. I'll just go back to my presentation. For European colleagues, it is paragraph here that you have to take into account in case of pre-tensioning. Okay, so you can calculate the length either with an Excel sheet or it will be much better to calculate it with a program BIM. So I'm centimeters. I chose it. I chose the tendons, and I have them here, as you can see. I have a pre-tension structure. I have 19. And here I can put the long-term losses for the serviceability limit state. Either you take this value from the program BIM, and I suggest you to work with program BIM. This is the diagram here. I don't have it. Doesn't matter. You can take this value directly from the program BIM, let's say 10%. Usually it is between 10 and 50%. And you can also change the distribution of the pre-stressing. This is the distribution of the pre-stressing, of the pre-stress force. And you can change also the values here. As you see, it now takes the real distribution into account according to Eurocode or according to the guideline. Or if you want, if you have another pre-stress value, then you can go back to combinations and manipulate the combination factors of pre-stress. So this is the second pre-stress tendon that I have. I have 19, I have 10%. Okay, and I need also to change the pre-stressing value. Okay. I think that it's okay now. I'm satisfied with it. So one that is missing is the shear reinforcement. I go with centimeters. I choose, I see the number of the rebars here. I choose the first stirrup. And as you can see, this is the reason I have different colors here. I choose orange colors with my mouse. And as you can see, I have all the stirrups. I select them and I export the stirrups. So here I would like to make a small pause and tell you something that many clients ask that, okay, if I have a system with a lot of load combinations, and I want to have 20 load combinations, 40 or more. So what can I do in this case? Do I have to input all combinations by hand? No, you don't need this. But in this case, you have to work with Beam, and you can export the geometry and the load combinations from Beam to detail. But there is a problem here. If you have, let's say, load combinations in detail, then it will take a lot of time. This is the first problem. The second problem is that you will lose control of your results. It will not be easy. So my humble proposal to you is to try to find combinations that they are critical. And it is not difficult to do it. If you have a simple supported beam, it's super easy. If you do not have a simple supported beam and it is a continuous system, then it is also not difficult to find, for example, load combinations with the maximum bending moment or maximum CR. You can work with 5, 6, 7 maximum load combinations, but you can work the way you want. I know that there are, colleagues and clients of ours that they work with 10 and 20 and 100 load combinations, but I know that it takes time. So this is my system. Okay, I put this right like this, and I put also the rebars in the openings. Okay, and I will go to the checking, and I will press calculate. Let's see what we have here. Let's try to count the time now to see how many seconds we need about this analysis. The program calculates with iteration because it is a non-linear analysis. It means that there is an actualization of the stiffness matrix because the stiffness changes for in every iteration. And we wait about the results. And it was something like 20 seconds. Think about it. In 20 seconds, you have the results of a precise non-linear analysis. Just think about it. How quickly it is just because we used the right multiplier. At the left side, we can see summary of our results for ultimate limit state and serviceability limit state. We see that there are it is okay. Ultimate limit state. I can see, for example, the strength. I can see here where the stresses are concentrated, as you can see. You can see also the stresses if I change it, right? 28 megapascal. I can see the stresses also in the reinforcement. Okay, you can see there are some stirrups that they are overstressed. I can see the tendons. Okay, I can see the band stresses about the anchoring. Here, the question that we got from some colleagues of ours is that if the program can understand if the constructions details of the guidelines are taken into account. The program will not tell you if you have to have a hook or not to have a hook. It is your responsibility as a structural engineer to put a hook here or not to put a hook. The program will calculate the bond stresses, and if there is not a hook, then this will have an influence on the resistance. It will have an influence on the formations. You will not get information from the program if the constructions details according to Eurocode or according to ACI are taken into account. This is a responsibility of the designer. Let's go now to the serviceability limit state. We can see here that we have some big values. I go to the characteristic. The characteristic is okay. If I go to the quasi-permanent, it is also okay. Let's see. Check. Okay. And let's go to, we can see also deflections if we want. For example, pre-stressing. See the deformed shape, how it is deformed. All of this taken into account the concrete tracking. Let's now go back to the reinforcement. And let me put these rebars away from the openings. Okay, and then let me go now again back to check. Sorry. And let's calculate it again. So we wait something like 20 seconds. I remember back, I think it was in 2000, I worked many years with the program Abacus. I was a research and development manager in a multinational company. And in order to have a nonlinear analysis with Abacus for such a beam, we needed hours. And this is the innovation. I mean, the method is not innovative, it is known. The nonlinear analysis used the last 2 decades. But what is innovative is that IDEA brought this analysis in the everyday practice through a program that everybody can use. You don't need to be a specialist in order to conduct a non-linear analysis. And this is really innovative. So as you can see now, 100% of our loads just reached 63% of the variable loads. And if you go to check, then you can see where the problem are. You can see the areas that they have the problem. So the program speaks to you. The program communicates with you. It tells you the areas where the pain is. So you can, in a surgical way, you can put the rebars at the right regions, and you can optimize the rebar layout. This is what detailing is, and this is what detail is all about. If at the end of the procedure you are satisfied with the rebar layout, cool feature is that you can right click and you can send your system to a DXF, and then you send the DXF to your draftsman. It means that you don't need to have any rebars to prepare rebar sketches. It takes time, so you can save time. You can save time with it. So what else? I'm just taking a look at my notes. Another thing is that if you want to tracing, we conduct usually long-term and short-term verifications with creep and without creep. If you want, for example, to change creep, to change the elastic modulus of elasticity of concrete, it's quite simple. You just go here to materials, and here you can find the creep factors. And you can see that we have two different creep factors for permanent loads and for pre-stressing. And even if you want to change the elastic modulus for the concrete, then you can click here. Okay, and as you can see, you can change here the values of the elastic, of the modulus of elasticity. So don't have anything else to show magic. I think that if there are any questions from our audience, we will be happy to answer them.
Okay.
Something. Sorry, Magic. Something that I forgot. Sorry. There was another question from some German clients, and that's quite interesting. And it is, okay, what am I going to do with the transverse direction? Okay, I have these hollow core slabs and have a torsion problem. With the program 2D detail, you can also investigate with a new analysis, also the cross section in the transverse direction. This is also possible in order to see cracks, in order to investigate torsion, in order to investigate you want to optimize the rebars in the transverse direction. So this is also possible. Okay. Sorry, Mate, it was the last comment from me.
No problem, Aris. It's always good to hear some more insights from you. So thank you very much for a very interesting presentation. Let me share my screen now. I will just... So
I can see your
thank you. Regarding questions, actually, the one that was posted, you have already answered. It was about the loads or multiple loads. If you can somehow make the process more efficient. So I think this one is already clarified. And right now, when I'm scrolling through the questions, I see actually no questions. So we can give 2 more minutes. 2 more minutes for the questions to come. In the meantime, I can proceed with other slides.
So Mati, what we can add is that in our internet site, we have very interesting articles. We have very interesting articles from our experts regarding pre-stress, and yes, it is really interesting for our colleagues to take a look in it.
Exactly. I think we'll get back. We'll get to this point. So starting with the campus, at our website, ideastatica.com/campus, you can educate yourself in both areas, steel and concrete. We have 2 courses for concrete and 3 for steel, so that's also a great opportunity to understand and learn the software better, and also get to know the theory behind the models that have been implemented in the software. And then let's proceed with the next slide. The next webinars that are about to come is the 8th of November. This is a really exciting one. It's about the new features in IDEA StatiCa 23.1. So please save the date for this webinar. We already heard what's going to be in the new version, and we are really excited to see this being released in the upcoming weeks. And another Connection Wednesday is planned for December the 6th. Then, regarding support center, so this is what Aris mentioned already. You can visit our website, and in the support center you will find loads of really useful knowledge, starting from knowledge-based articles, going through tutorials and videos showing how to use the software properly. So feel free to go there. And what Arsi also mentioned, it's a lot of really interesting articles about prestressed concrete. Yes, and I see that right now we have a few questions coming in. Aris, can you have a look at them?
Yes, one question I see that if it is possible to calculate the hollow core slabs. Yes, I mean you just need to give the cross section of the hollow core slab in detail and then you can without problems calculate the hollow core slab. But the hollow core slab can be calculated also with a BIM program. You can also use both programs and compare the results. Okay. No, they were both pre-tensioned. But if the question is if post-tension can be used as well, yes, post-tension can be used as well. Yeah. If you want, another question has to do with stage construction. Take into account staged construction and the so-called loading history, then you can, of course, work with the program BIM, and you can investigate separately the stages with the program detail. We must not forget detail is for detailing. Detail is not for global analysis. Global analysis do it with BIM, and the detailing areas that they are challenging for the rebars, for your reinforcement, for cracks. This is where you put a detail. And okay, I mean, these are the questions that we have.
Exactly, I think that
Magic.
we have covered the questions.
Yeah. Otherwise, they can the colleagues, they can contact the local experts. We have a lot of experts in different subsidiaries. We have experts that they develop the program in our headquarters, and they will be more than happy to assist you and to ask your questions. And don't forget very interesting articles in our internet site.
Exactly. So if any of the questions have not been answered, then we will get back to you via email after
Yes.
the webinar. There was also a question about the recording. Yes, it will be available in our support center or our YouTube channel. So yeah, I guess it should be available tomorrow. So yeah, I'd like to say thank you all for joining us today, and remember that you will receive a short survey after the webinar is over, it'd be great if you could fill that in for us so that we can learn from it. And also, yeah, please look out for the following webinars that I mentioned earlier. And yeah, thank you very much. Have a
Thank you.
great rest of your day. Many thanks.
Thank
Cheers.
you. Take care. Bye.